4-bit full adder. Okay, so what is a 4-bit full adder means? Till now, till now we discussed only one bit, like 1101 like that. Now let us take 4 bits. Okay, let us take 4 bits means I want to consider A as 4 bits and B as 4 bits. Okay, so for that the first thing is, for 4 bits, for A you need to assign some binary number. Okay, so let us take 0 0. As I am saying that it takes 4 bits, so I am taking 0011 and B as 1 0 0 1. Okay, now you try to assign. So why? Because for this to implement 1 plus 1 you have to take one full adder. Try to concentrate. And for this you have to take one more full adder. Okay, so totally how many full adders we need to take in order to add 4 bits? In order to add 4 bits, how many full adders we need to consider?
4.
4 full adders, right? So let me give with an example. Let me consider A as A0, A1, A2, A3. Okay, A1, A0, A1, A2, A3, and this as B0, B1, B2, B3. Okay, now okay, so as we are discussing full adder, so full adder already know, everyone knows that it takes three inputs: A, B, C in. This is your A, this is your B, this is your C in, and the output will be, one is carry out and the other one is sum S. Okay, so as we are taking each for each for one to add, we are selecting full adder. So you will be having C naught. Next, whenever there is generated carry, this carry will be going here and you will be having C1. Next, C2. From this, if there is any carry, means if A1 is 1 and B1 is 1, you will get sum will be stored as 0 and carry will be stored in the next bits. So from this you will be placing carry C2. Okay, and from this you are placing the carry C3, the one which here. Okay, and from this you are placing to C4. Okay, so this is your process. Now let me take with an example. Let me take with an example. 0 0 0 0 1 1, and the B bits we have considered as 1 0 0 1. Okay, now tell me, 1 plus 1 is what? Everyone knows the binary rules, right? 1 plus 1, 1 plus 0, 0 plus 1, 0 plus 0. Okay, so these are the rules that everyone has to know. This is your sum, this is your carry. So sum 0 will be placed, in carry 1 will be placed. In sum 1 0 1 0 0 0. Okay, now according to 1 plus 1 means sum will be 0 and carry will be 1. So C1 is now 1. Now what will be the result, ma? 1 plus 1 plus 0. So let me go for 1 plus 1. 1 plus 1 is, the result will be 1 0. So what we will be getting, 1 plus 1 means it is 2. So 2 plus 0. So 0 will be placed here, 1 will be placed here. Next is 1. This is carry. C3 is carry. So from here, if there is carry generated, we will pass. If there is no carry, by default, we will place 0. Next, we will be having 1. Now tell me this number. 011 is what number, ma? 0011 is number
3, ma'am.
3.
3. 1001 is what? 18421. You try to assign. What number is this?
9, ma'am.
9, ma'am.
9 plus 3 is what?
12.
Do we got
12,
12?
ma'am. Yes, ma'am.
Yes. So
Yes, ma'am.
this is your answer. Okay. This process need to be used in order to generate. So for that, according to this diagram, you try to concentrate. So according to this diagram, I want to design a circuit which acts as 4-bit adder. So for that, what I have to do? I have to take one full adder, and for as we have four, so totally we have to take four full adders, and we need to take two AB and one from carry in. Carry in. So from this, if there is any carry generated from this AB, this has to be passed to next bit. Why? Because here we are passing to next. Okay, so this has to pass. So this will become carry in. So next this has to pass. This has to pass, and finally this file is carry in. So this is your 4-bit adder. So see here, this is your 4-bit adder, 4-bit full adder, binary adder. So here we have given A0, B0, A1, B1, A2, B2, A3, B3, and C0. Okay. Now according to this example, fast answer ma. According to this example, A0 is 1, B0 is 1. Okay. So A0 is 1, B0 is 1. So this C0 will be by default 0. So what the sum will be generated 0 and carry will, let me draw this one so that you can understand even more clearly. This is A0, the other one is B0, A1, B1, A2, B2, A3, B3. Okay, and this side will be have two outputs will be generated. One is carry and the other one is sum. This is S0, S1, S2, S3. Okay, from this there will be C0. I'm just writing carry in. Okay, C. This C will be passed from this. And finally, if there is a carry generated from this, you will be getting here. You will be getting here. Just a minute. No? Okay. Hmm. So let me give the what we have selected. So A0 as 1, B0 as 1, A1 as 1, B1 as 0. Next, A2 as 0, B2 as 0, A3 as 0, B3 as 1. Okay. Now, so initially C0 will be 0. Now, according to 1 plus 1 will be 0 and the carry will be generated and this will be passed as 1. Okay. Now, 0 plus 1, 1. So, 1 plus 1, this carry is also giving as the input as it is full adder. It takes 3 inputs. So, the generated output will be 0 and carry will be 1. So, here 0 plus 0 is 0, 0 plus 1 is 1. So the sum will be 1 and the carry generated is 0. Next 1 plus 0, 1, 1 plus 0 is 1. So 1 and the carry generated from this output is 0. So finally the output will be Okay, so this is your full adder. So this is your full adder. Hope everyone understood. Okay, is it clear, man? So see here, why this is called as carry ripple adder. See this, in order to implement this in a system, we will be going for IC, integrated circuit. So the integrated circuit will be looking like this. See here. So here it will be in one IC it will be given as four inputs, B0, B1, B2, B3, and four inputs, A0, A1, A2, A3. Okay, if I show directly this one, you cannot understand. So initially I started with four full adders. These four full adders can be implemented directly. It will be implemented in the IC if you want to represent in a system. So that is, you will be giving four inputs from here, four inputs from this, and finally outputs will be generated. Okay, so this is your IC, 4-bit adder IC. So we'll be calling this as carry ripple adder also. So why? Because try to concentrate, ma. It will be working as, there will be some delays. So why there will be some delays is that it will not be working as parallel adder. So see here. So once if this is completed, then only the based on this output you will be passing to this. Based on this output will be passing to this. Based on this output will be passing to this. Means what? There, for each and every circuit, to complete this, let us consider it takes one nanoseconds to complete. So see here, it has taken output after 4 nanoseconds. So there will be some delay. So in order to execute this for each and every from this circuit, it takes some time to execute. Next, it has to wait. Once it's completed, it has to wait. Like it is in serial fashion. So there will be some delays in that. So we'll also be calling this as carry ripple adder behavior. Okay. So next, everyone write down side heading binary adder subtractor. Okay. So in binary adder subtractor, everyone knows that instead of subtraction, as we have instead of subtraction, we are going for adder. Why? Why? Because when we are going for a subtraction operation, as there are borrows are more, so the complex it increases the complexity. To overcome that, what we are doing is, instead of going for a subtraction operation, with the help of two's complement, we convert it to addition. Okay, we convert it to addition. So for that, what we are doing is, we are going for two's complement. So try to concentrate now. So we are going for two's complement. So what I am doing is, so I have taken same of adder. Okay, so 1a, so you must know, will be represented as a plus minus b. Okay, so for this minus b to implement, what we are doing, we are doing one's complement for that. We are doing one's complement for that, plus 1, so that we'll get two's complement. Okay, so for that, what we have to do, let me consider this as a0, a1, a2, a3. This I have to take directly. A0, a1, a2, a3. This I have to take directly. Coming to b, so coming to b, so this is your b. Okay, so this is your b. So what I'm doing is, it should not be, it should be minus 1. So I have to implement one's complement. So that what I will do is, I will apply not. So if I apply not, what happens? Can anyone? If I apply not, what happens? Fast. If I'm giving for this input as 1 0, if I'm giving the input as 1 0 0 1, from this output, what you will get?
0110.
0110 means I done with one's complement. Okay, next adding 1 to this, by applying you will get. But the problem here is for subtraction, there should not be one separate circuit, and for addition, they should be one circuit, I see, in such a way that based on one switch, based on one switch okay, based on one switch, it has to it has to decide it has to decide what? It has to decide based on the switch, whether it is working, this IC is working as adder, or whether this IC is acting as subtractor. Okay, so we should not do anything. The only we have to use an adder, and adder based on the switch input that I applied. So in this switch, if I am placing 0, that means this entire circuit will be working as adder. No, I don't want this adder circuit to be working as adder. It has to be work as subtractor. So what I will do, I will convert the switch from 0 to 1, so that this entire switch in IC will be working as subtractor. So how to do that is, try to analyze, is there any gate which converts, given an input which converts, if it is 0, concentrate ma, this is very important. Try to concentrate, and the topic that I am discussing is also very very important topic. Okay, so let me go for XOR. So XOR is, already I said that it is odd one detector. So you will be having A, B, and you will be getting output. Concentrate. So you will be getting 0 0 0 1 1 0 1 1. Okay. Now tell me, if it is XOR, what's the output? Output 0 0 means what output will get ma for XOR odd one detector? Am I audible?
0110.
Okay, 0 1 1 0. Okay, okay. Now concentrate. I already said that. So if it is addition, if it is addition, I want B to be represent as it is. So let me consider B equals to B naught, B1, B2, B3. Okay. So let me take the B as 1 0 0 1. Okay. So if I want this to act as adder, if I want to add this IC as adder, I want to send B as it is. Means if I'm giving 1001, I have to get 1001 only. Okay, I don't want to do any ones complement of that. So to this switch, what I have to apply is 0. Why? Because see here, if you are giving switch one input to XOR gate 0, are we getting A or are we getting B? అవుట్పుట్ చెక్ చేయండి అమ్మా, ఏమొస్తుంది అవుట్పుట్? 0 1. Okay, so 0 1 you're getting. Now let us consider, instead of taking the switch as 0, I want to take the switch as 1. Let us consider, okay, 1. So what happens if for this input there will be an XOR, everyone knows this. Okay, let's try to concentrate. For this input, I want to give one input as B naught and the other input as switch. Okay, this switch will be common for all. Okay, so if I'm giving this as 0, concentrate, and B naught, based on the value B naught, we have 1. So what will be the output? 0 1 1 means, are we getting B naught or are we getting yes switch? We are getting B naught. Okay, so in the same way, consider switch as 1. Concentrate ma. In the same way, consider switch as 1. So I'm placing 1 and I'm given 1. Okay, so what is XOR output? 1 1 means what you are getting? Are you getting A or are you getting B? 1 1 means what's the output? ఏమైందమ్మా, వింటున్నారా లేదా?
1 0 ma'am.
So if you are giving input as 1 1, the output is 0, right? So here 0 means, given an input 1, it is converted to 0. Let me give 0. Let me use 0. ఇప్పుడు ఏమొస్తుంది ఆన్సర్?
1.
1. Okay, so you are getting 1 means what? So if switch is given as 1, the B input is getting complement. Are you getting? One point you try to notice, if switch is 0, if switch is 0 and the B naught is 0, this is your B naught, and you are applied for XOR, and the output will be what? 0 0 means the output will be, if one input is 0, it depends upon B, so you will get 0. Okay, means what? Same b not value ఏమైతే ఇస్తున్నారో, the same value you will be getting as 0. So this will be acting as adder, this will be working as adder. Now if I want this circuit to be working as subtractor, I want B as complement of that. Once complement, I have to implement one's complement. For that, what I will do is, I will convert this to 1. సో అప్పుడు ఏమవుతుంది, ఇఫ్ ఇట్ ఈస్ వన్, if it is 1, the b input if it is 0 you are getting 1, the b input if it is 1 you are getting 0, means what, the complement of b we are getting. So that's the reason we need to consider if it is 0, whatever the input that we are passing 0 1, we, exactly the output you will be getting 0 1. So if I want inverse of that, then the input should be, one of the input should be 1. So if one of the input is 1, the b naught 0 if you are giving, the output will become 1, if you are giving 1 the output will become, so it is acting as 1's complement. So it is acting as 1's complement. Is it clear everyone? Having any doubts in this? Okay, so this is a way. I don't want one circuit for subtraction using 2's complement. I don't want one circuit for adder. In one circuit only, based on the switch input that I applied, it has to work as adder or it has to work as subtractor. So that you can even more clearly you can understand if you know X or A. Okay, so see here with the help of a diagram. So this is your binary adder subtractor. The subtraction a minus b can be performed by taking 2's complement of b and add it to a. Okay. So and the 2's complement of b can be obtained by complementing b and adding 1 to the result. Okay. So this is your 2's complement. Even I know that only half student knows how to do 2's complement. Again I am repeating. So 2's complement form. So in order to do 2's complement, what we have to do, first of all, take a binary number 13. So this is your binary number 13 represented in 5-bit representation. So 0 1 1 0 1. Okay, so convert that to 1's complement. So what you will get, 0 1 1 0 1 means you will get 1 0 0 1 0. For that, add 1. So that finally you will get the result as 1 0 0 1 1. I already said that how to identify this is a in negative representation is the most significant bit 1 is there, that means the resultant is negative number. Again if you do 2's complement you can find out the actual number. Okay, so this is your 2's complement. So here now everyone, the XOR gate should be applied for A or B. The XOR gate should be given for A or B.
B, ma'am.
B. So why? Because B must be, you have to convert that to 1's complement. B, not A. A have to be taken as it is. So this is your 4-bit binary adder subtractor. So A I'm considering as it is A naught, A1, A2, A3. But for B, I already said that it depends upon the switch that we have selected. Yes. So in this, if this is 0, the circuit will be acting as, it is a 4-bit binary adder and subtractor. Based on this input switch mode, it decides whether it works as adder or whether it works as subtractor. Now consider this as 0. So if I am placing this as 0, this entire will be working as adder. Why? Because if you place 0, whatever the input that we are placing, b0, b1, b2, b3, the output will be b0, b2, b3. The same output you will be getting. Okay, now instead of the switch if I place 1, so what happens, we'll get b naught complement. So we'll get b naught complement. So let me draw this and let me explain with an example so that even more clearly you can understand. Everyone meanwhile note down the XOR truth table and individually give XOR one as switch and one as b naught, and you try to represent for which you are getting adder, for which you are getting subtractor. This is very important, ma. So this is your one full adder. This is one more full adder. I should draw down so that you can understand. Okay, one will be directly you're passing A naught, A1, A2, A3. Okay, one is A naught, A1, A2, A3, and the other one is XOR. XOR. What will be one input for XOR for this? One input will be what? One input will be B naught, B1, B to B0, B1, B2. This is B2, A2, B. Next is B3. Okay. Next. Wow. What will be the other input, ma? The other input is what? The other input is what for XOR? One input is B0, B0, B1, B2, and the other input is your deciding mode, logic mode. Yes. Okay. Now, now see here, there is an output. Same. There will be as we are full adder, there will be C. So this from this again it will be passing C, and from this it will be passing C. And from this it will be passing carry in, and from this you will be C. Okay, and here you will be getting sums. Okay, so two outputs, as we know, full adder there will be two outputs, one is carry and the other one is sum. Yes, not yes, one, yes, two, yes, three. Now let me give with an example so that you can understand clearly. Let me go for uh, 3 minus 4. Okay, so how you will write 3 plus minus 4? Okay, means what we will do, we will represent this 4 as it is. Okay, 3 is represented as 0 0 1 1, and 4 is represented as 0 1 0 0. Okay, so let me write for this one. So how to write, ma? Where is a? So here is a, so you will be 0 0 1 1. Okay, next is what? 4. 4 is everyone knows, right? B0, B1, B2. So here as it is B3, so in B3 position you have to write 0. Next is B1, next is 0, next is 0. 0 1 0 0 4, 0 0 1 1 is 3. Okay, now as we are taking directly, you will get the input here directly as 0 0 1 1. Okay, leave about the other side, we need to concentrate. The other side I am giving as 0. S, the input mode I am deciding as 0. So now tell me what will be the output from this 0 0. Let me start from this 0 0 means what we'll get. Fast, ma.
Zero.
0 0 means you will get 0. Means given a input 0, you have to get B naught value only. 0 B, you got B, so B, you got B here. Now B1 is 2. 2 0, what you B2 1, and the other combination is 0. What will get? 1 0 combination is input for XOR. What will get? 1 or 0?
One.
1. Okay.
One.
Here 0 and 0. What will get? 0. Next. Next is 0 0. What will get? 0. Means are we getting the same B3 value? Yes. 0 means we got 0. Here B2 value as 1. We got 1. B3 B1 value as 0. We got 0. B0 value as 0. We got 0. Means it is acting simply as adder. If this is 0, this will be working as adder. So there is no more changes. Same like the previous concept. We are adding 0 here. So the result will be 1 and carry will be 0. And the result will be 1, carry will be 0, and the result will be 1, carry will be 0 0, and the output. So in this way you have to do the simple addition. So you will get the addition 4 plus 3 as 7. So we got 7, simple addition. Now we need to do subtraction, so that we have to get 3 minus 4 means you will get minus 1. So minus 1 will be in 2's complement. Again if you do, you will get 1. So for that what we will do, addition is over. Now let me see whether this is working as subtraction or not. So for that I have to convert this to what? 1. So now tell me fast, what will be the output for this? Tell me. If one input is, the other input is 1, so you will get 1. What will be the output here? If it is 0 1,
One.
1 means if we input we are giving b3 as 0, the complement of that we are getting. Okay, the complement of that we are getting. Now b2 is what? B2 is 1. 1 and 1, what we'll get? 1 and 1, 0.
0.
Okay. Next 0 and 1,
1.
1. So 0 we are giving as input. So we are getting the output as 1. Okay. So same. If you are giving 0 and 1, the output will be 1. Okay. So we will get as uh, the opposite of this. So if you are giving 0, you are getting 1. So 1's complement completed. So let me write this one. So you will be ended with 1, 1, 0, 0. This is A. And B, what we will get? B as 1, 1, 0, 1. Means if there is 0 here, I have written this is A naught, B naught, A1, B1, A2, B2, A3, B3. Okay, the same A I have written here 0 0 1 1. B as the switch is 1, the complement of that I have written 1 0 1 1. Now perform addition. So for this the input will be 2 2 and this is 0. So what we will get if you perform addition? 0
0 and carry 1.
carry 1. Now what will get the output? Triple 1 means
1 and carry
1
1.
carry 1. Next what will be the output? 1. For this 1. Okay, so the result they generated is what? Finally 1 1 1 0. Okay, so you need to find out whether this answer is correct or not. For that, you by saying in the most significant bit there is a 1, that then you got a negative number. To generate this to okay, sorry ma, here we will get 1. So why we will get 1? Why? Because this will be same, this carry in and C will be same. See this diagram. So this if s equals to 0, we'll be getting C naught as 0. If s equals to 1, we'll be getting C naught as 1. So finally what we'll be having here? 1. So if you give 1 here, you will be getting 1 here and you will be getting 1 here. So finally you will get what? Tell me the sum and tell me the answer, ma'am. So the previously we have considered this 0, but this is for adder. As we are considering this as 1, here also we will be getting 1. So why? Because we are taking this as an input. So here also we will be getting 1. So we will be 1. Tell me and what will be the answer? So triple 1 means 1 1. Triple 1 1 1. So what will be the answer? Notes లో చేసి చెప్పండి అమ్మా ఏమొస్తుంది ఆన్సర్. What's the final answer? 30, 31, 32, 33, 34, 35. Is 35 better or 34? So A naught, B naught, A1, B1, A2, B2, A3, B3. Okay. So A I am writing as it is 0, 0, 1, 1. So B as S equals to 1, the complement of that will be generated. So you will get 1, 0, 1, 1. And C in will be base, this will be connected to S. If S is 0, you will be getting 0 here. As S is 1, you will be getting 1 here. Okay. Now tell me. Uh, fast. Please tell me the answer. Final
1 and
result
carry 1.
1. You will be getting 1 and carry 1. Again, you will be getting sum as 1 and carry 1. You will be getting 1. You will be getting 1. So final output is what?
4 1.
So this is a negative number. Why? Because in the most significant bit, if you find it there is a 1, then it is a negative number. So in order to convert which number is negative, which number is this negative number, convert this to 2's complement and tell me what value you are getting. 1 1 1 1. First, if you do 1's complement, 0 0 0 0, and add, if you add 1, you have to get finally as 0 0 0 1. What's in the subtraction result?
Yes,
Yes.
ma'am.
Okay. So in this way, this circuit will be acting both as adder and subtractor based on the switch. So if this is s equals to 1, it will be acting as an adder. If this equals to 1, it will be acting as a subtractor. And try to find out carry. C naught initially will be connected to sum. So why? Because if it is 1, along with 1's complement, even we have to add 1 to the 1's complement to generate 2's complement. That's the reason that we have given carry in as 1. Understood why this carrying should be by default 0, but after converting 1's complement, in order to generate 2's complement, we need to add 1. That 1 we are adding by using this carry in. Okay, this completes your 4-bit binary adder subtract.